Welcome in this second video on the trigonometric circle. In the first video we've seen that the coordinates of the point here that makes an angle alpha with the x-axis as coordinates cosine alpha and sine alpha. We just applied basic trigonometry to derive this result, and it's worth taking a look at the reason why trigonometric ratio were first only defined for angles between 0 and 90 degrees. If you have a look at the right angle triangle here, you see that the sum of the three angles should be equal to 180 degrees. Because this one here, the right angle, is already 90 degrees, you see that none of the other two here can be greater than 90 degrees. So this means that on the trigonometric circle we worked on, this angle alpha, that was one angle in our right angle triangle, could only be between 0 and 90 degrees. In this video, we are going to see what happens if we try to extend sine and cosine here to angles that go beyond 90 degrees. So let's now have a look at what would happen if the angle is greater than 90 degrees, let's say 120 degrees, for example. So if this angle here is 120 degrees. Our point would be here, and so you could read the sine of 120 degrees here. You see it would be a positive value, somewhere between 1 and 0. And the cosine can be read right there. So here we'd have the cosine of 120 degrees. You see that this value is expected to be negative somewhere in between 0 and -1. If now you take this point and you drag it in the third quadrant here, you see that the cosine of this point is going to be negative, and the sine of this point is also going to be negative. So that's for angles that are in between 180 degrees, and then the angle of 180 is there, and 270 degrees. Now, in the fourth quadrant, we find points that correspond to angle between 270 and 360. You see, if you take a point right here, for example, you see the cosine is going to be positive and the sine is going to be negative. So this all relates to the fact that the x-coordinate of this point is interpreted as the cosine and that the y-coordinate can be interpreted as a sine for the angle here that it makes with the x-axis. So let's now have a look at some interesting angles that we relate to a given angle alpha. You see, if you reflect this radius here in the y-axis, you will get this line segment here. If you reflect both of these in the x-axis, you will get this one and this one. The interesting thing to notice is that here we find four equal angles equal to alpha. And so, the interesting values of the angles for the 4 points on this circle here are 180 minus alpha, and this is clearly shown by the fact that you do 180 and then you subtract alpha to reach this point. 180 plus alpha, so again you get 180 and you add the alpha here to get 180 plus alpha. And finally, 360, which is a complete turn, minus the alpha found here, to get this 360 minus alpha. You see that for symmetry reasons, these 2 points, for example, have the same x-coordinate. This means that the cosine of this angle alpha is also going to be the cosine of 360 minus alpha. Similarly, you see that these 2 points here, they have the same y-coordinate. So this means that the sine of 180 minus alpha can be expected to be the same as sine alpha. So let's have a look at how this can be used. Let's pretend that this angle alpha here is 30 degrees. Because cosine of 30 degrees is square root of 3 over 2, and sine of 30 degrees is 1/2. So let's work with these exact values that we are supposed to know for the exam. So we have square root of 3 over 2 and 1 over 2. So this means that the coordinates of this point here are square root of 3 over 2 and 1 over 2. And let's see now what we can say about sine of cosine of the related angles that we have here. This 180 minus alpha is 180 minus 30, so it's going to be 150 degrees. The 180 plus alpha that we have here is going to be 180 plus 30, so it's going to be 210 degrees. And finally, the 360 minus alpha here is going to be 360 minus 30, so 330 degrees. So let's check what we can say about the sine and cosine of these angles. So let's start with the cosine of 150 degrees. 150 degrees is this angle here, so this point here represents 150 on the trigonometric circle. The cosine of this point is its x-coordinate that you read here on the x-axis. For symmetry reason, you see that this value here is going to be the inverse of this one. So this is what we can say that the cosine of 150 is minus square root of 3 over 2. If we then have to look at the sine of 150, the sine is read at the y-coordinate of this point, so you see it's going to be exactly the same thing as the sine of 30 degrees. So this is why here we can say that the sine of 150 is going to be half. Let's repeat this with 210 degrees, so the point representing 210 is right here. So the cosine of 210 degrees can be read as this value here on the x-axis. You see it's exactly the same as the one we had for 150. So let's write that this cosine is again minus the square root of 3 over 2. And its sine can be read here on the y-axis, and you see that this sine is going to be the inverse of the one we had here for symmetry reasons. So this is going to be minus 1 over 2. Finally, if we repeat the same thing again for 330 degrees, the cosine is read right there. So it's the same as the cosine of 30 degrees. It's the square root of 3 over 2. And the sine is read here. It's the same as the sine of 210 degrees. So it's going to be minus 1 over 2. And there is one general rule that we can derive from this example. You can see now that angles between 0 and 90 degrees are going to have a positive cosine and a positive sine that will be read on these parts here of the axis. If the angle is now between 90 and 180, you're going to be somewhere here. So the cosine will be read somewhere here, it's going to be negative, and the sine somewhere here is going to be positive. So angles between 90 and 180 have a negative cosine and a positive sine. Angles between 180 and 270 here are going to have a negative cosine, read somewhere here, and a negative sine, read somewhere there. And the angles in between 270 and 360 are going to have a positive cosine, read somewhere here, and a negative sine that they will read somewhere there. I hope this helps. The next video is going to be on drawing graphs of sine and cosine.